Hey, we're going to continue to talk about types of reactions. So if you'll recall, in my resource folder, I have chemistry formulas, equations, and constants. It's a handy little reference sheet. So you have synthesis, decomp, single, double, neutralization, combustion. These two are like neutralization, same thing as a double. Okay? And then don't forget, you'll also need to refer to your activity series of metals and halogens. So in this first example, we have calcium carbonate, and it's a solid. And notice this is just one reactant, and I know from my little sheet, I know that one reactant breaks apart into two simpler things. So I already know this type to be a decomposition. Okay, so I need to think of two simple things that this can make. So the decomps are the hardest ones for high school chemistry students to think about, but if this were to break down, it's going to make calcium oxide, which is a solid, and it's going to make carbon dioxide, which is a gas. Okay. And then I see I have 3 and 1 each, and so it's balanced, and we don't need to do any coefficients. Okay. Here we have lithium hydroxide in water. A metal oxide in water will end up producing a metal base, which is called lithium hydroxide, and then this is soluble. And this type of reaction ends up being one that produces one product, so it's synthesis. All right, here we have strontium bromide reacting with ammonium carbonate. So I notice I have a binary ionic and pseudo-binary ionic compounds, and these are the positive portions are going to swap, so we're going to make up with ammonium bromide. And then this is going to be soluble, and strontium carbonate, which is a solid. Ooh, I didn't go back and balance this. You should have said, hey, you didn't balance this, so I need 2 of those. And now we have 2 lithiums, 2 hydrogens, and that's balanced. Okay, good. And then over here, we've got ammonium bromide and strontium carbonate. We need 2 bromines, and we have 2 nitrogens, and that's 8 hydrogens, 1 carbon, and then the 3 oxygens. So that's balanced, and that's an example of a double. Here we have lithium reacting with water to produce, if you look at your little sheet, lithium is on our sheet. Lithium can replace the hydrogen and water. So if lithium replaces the hydrogen and water, we end up with lithium hydroxide, which is soluble, and hydrogen gas. And that's an example of a single. And then we need, let's see, what all do we have here? We have 1 oxygen, 3 hydrogens, so it looks like we're going to need to make that 4 hydrogens for 2 oxygens and 2 lithiums. Okay. Here we have cadmium, which is not on your list, but if you look at other lists, you would notice that it could be just this particular sheet that I use. It's not on here. But cadmium would replace hydrogen in an acid to make cadmium sulfate, which is soluble in hydrogen gas. And then this is a type of single. And we can see that we've got 2 hydrogens, 1 sulfate, 1 cadmium, and that's balanced. Okay. And then we have aluminum reacting with manganese oxide. That is on our little list. And we've got aluminum can replace manganese. This one I just happened to use one that's not a metal, that I could have used some other metal like calcium. I should have, but I just printed this off from my sheet of things that I have to work with. So we got aluminum oxide and manganese, solid, and then aluminum oxide is also solid because it's insoluble. And then this is an example of a single. And then we can see that we have 2 manganese, 3 oxygens, and 2 aluminums. Okay. We've got calcium hydroxide and hydrochloric acid. And we see from our little list, calcium can replace the hydrogen in acids. So we end up with calcium chloride, which is soluble. That needs to be a 2. And water, which is a liquid. 2 and 1, so I'm going to need 2 of those and 2 of those. And then this is an example of a double or neutralization. And then we have magnesium nitride. It's going to break down to just simple elemental magnesium, which is a solid, and nitrogen gas. And this is decomp. And so we end up with 3 magnesiums, 2 nitrogens, and then we've got a balanced equation. Okay, and that's how you can complete those and predict the products and identify the types. And then I have a few more that I can do with you here. Okay, so I have copper reacting with silver nitrate, and I see from my little list here that copper can replace silver. So we're going to make copper 1 nitrate. Ooh, I'm going to run out of room. Good lordy. And silver. I need to write smaller, but I wanted to write big enough so you can see it all. So then this is just copper, silver nitrate, making copper nitrate and silver, and it's balanced, and that's an example of a single because one element replaces another. Here we have fluorine reacting with sodium bromide. Now I know that. And then this ends up being solid, so that's how come this works, and that's soluble. And then we end up with our halogens. So I can see that fluorine can replace bromine to make sodium fluoride and bromine. Okay, and so we have a diatomic and an ionic compound, making an ionic compound and a diatomic. And then this is a gas, this is solid, and then I need 2 of those and 2 of those, and that's another example of a single. Okay. And then we have iron reacting with copper 2 sulfate, and I see from my little list that iron can replace copper. So we're going to make iron 2 sulfate and copper. And that's balanced, and that's another example of a single. Okay. Let's see, what do I got here? Let's do this. Okay. We've got tricarbon octahydride. Well, remember, I said anytime you have carbon reacting with oxygen, you always make carbon dioxide and water. Whoops, running out of room. Okay. Tri means 3. Octa means 8. Diatomic carbon dioxide, water, and let's see. Will 3 work here? I'm gonna need to go up more. Let's see. I don't want to write that and then have, because I can't erase. If I do 3 here, that's 6 and 4. Yeah, that'll work. So 3 and 4, 6 and 4 is 10. Yep, so 5. And then we got it balanced, right? Yep. And that's an example of combustion. Okay. Let's go down here to this one. We got, I think I did this one already with you on another page. Did not? Yeah, I already did that one, so we won't do that one. It's another combustion. Oh, this one's a good one. Potassium cyanide and hydrobromic acid. So I see that potassium can take the place of hydrogen in an acid. So we're going to make potassium bromide. And that's going to be cyanide plus a hydrogen makes cyanic acid, or hydrogen cyanide. Okay, so we got potassium cyanide, hydrobromic acid. Basically the positive parts swap places, because see, that's positive, negative, and then you end up with potassium bromide and hydrocyanic acid. I should have said hydrocyanic acid there. Oops. Okay. And then that's balanced, and that's an example of a double. Okay, let's see what others do I have to show you. Oh, that's another example of a double. This is a decomp. This is going to make and then we've got this is going to make aluminum iodide. And that's a synthesis. And then here's another example of a combustion, glucose, oxygen, making carbon dioxide and water. And that's another example of a single. Rubidium and silver swap places in a double. Sodium, manganese swap places in a double. Lithium and molybdenum swap places in a double. Do I have any others? Example of a single. And another double, single, double. Okay. All right. So hopefully that's enough worked for you, that you get the main idea of how to predict products and complete the reaction, balance the reaction, and identify the types. All right. I'll talk to you later. Bye.